So the continuous function police show up and they look at the domain and say, okay, it's all of this and all this. So they take the little marker and say, all good, and then I don't check here, and then I'm here, all good. That's a continuous function. Now if I asked you, is the 1 over x function continuous on the interval -1 to 1? No. Continuous on an interval, this graph is discontinuous at x equals 0. The 1 over x function is not continuous on the interval -1 to 1. However, it is still considered a continuous function. Do you see the difference between those two, the way that word's used? Interval and function? Yes or no? Okay, so just be careful how the word is used. If something says it's continuous on the interval, you're all good. There are no breaks. There are no discontinuities. If it states specifically it's continuous on a closed interval. If it says it's a continuous function, just be careful. Okay? Does that make sense to you, Ida? Just be careful. Something to look out for. Okay? So what's fun about all that is, so you have all these continuous functions, then you do any operation with them. If you add two functions, if you subtract two continuous functions, multiply them, divide them, as long as the 1 doesn't equal 0. You can do any of these function operations, and your new function will also still be continuous. You can also do a composition of functions. If you compose two continuous functions, your resultant function is also continuous. And that's kind of a big deal when we get to chapter 3, this whole composition of functions idea, and the new one is also continuous. Any questions on that? Yeah?
Well, going back to the continuous on the domain, so you can can you just, if there's just a hole, can you just exclude that in your domain? And then it would be continuous on this domain?
Sure. If you define a function like that.
Like if there's a hole 4, you could just write the same thing, just as long as you just exclude the hole from the domain.
Yeah, if you define your function to be all the values of x, not including that one, that would be a continuous function on its domain. Yeah. Yes?
What's the case then?
A number, so that's just any number. So it's like if you multiply, since x squared is continuous, 2 times x squared is also continuous. 7 times x squared is continuous. So you multiply it by any number, and that's true for any of these. Does that make sense? Okay, great question. All right, our first big theorem in calculus is the intermediate value theorem. That's why there's a little star next to it. It's kind of a big deal. It's an existent theorem. I mean, it's not going to help you calculate any values. It's not going to help you solve anything. It's just a way to prove that something exists. All right, so I'm going to read it and we're going to talk about it. The intermediate value theorem for continuous function. And you can paraphrase that or simplify with IVT. A function f of x that is continuous on a closed interval, meaning every single point is continuous, not continuous function. You see that, Allie? It's continuous on a closed interval. It takes on every y value between the function value at a, the first endpoint, and the function value at b, the second endpoint. In other words, if there's some y naught between those two y values, then that y value is equal to f of c for some c in ab. Meaning there's some x value that'll give you that y value. What that means is if a function is continuous, and it goes from, it outputs -1 to 3 on some x interval, so it has y values of -1 to 3, then there are specific x values in that interval that will have all the y values between -1 and 3. Meaning you can prove, if you just tell me you have a continuous function on a closed interval, and it goes between -1 and 3, then you can prove to me, by intermediate value theorem, that at some value, you have to go through 2. And that's all it tells you. Let me show you another example. I'll draw a little picture. And again, this doesn't have to be solved anything. It's like, well, what's the point of that? We'll get to that. So, let's go from the point 1, -2 right here. going to start there, and we're going to go all the way up to our friend 4, 3. You have some continuous function on the interval, the closed interval. You need the endpoints included. You have a continuous function on the closed interval 1 to 4. I don't care what happens in between the 1 and the 4. It can look like whatever you want. I don't know. I don't care. It's a function. It does something in between that 1 value and the 4 value. But if I know f of 1 is -2, and I know f of 4 is 3, that's all I need to know in order to prove that at some point you have to go through 0. You have to. You can't jump over the x-axis. Yes?
Is that only if it's continuous?
Does that make sense? It has to be continuous. Otherwise, you can have a jump discontinuity over it. So that's why you have to have a continuous function on the closed interval. Continuous. It has to. If you could prove to me that it's continuous, or if you're told that a function is continuous on a closed interval, and you have those two values, and one is below your value and one's above your value, by intermediate value theorem, there exists some point, some x value. Again, I don't know what this x value is, and that's why they just call it c. There's some x value c where f of c, or the y value, is equal to 0. There may be a couple, like in this case I drew a whole bunch, but there has to exist at least one. Yes?
What if 1 and 4 are not included? So then
Doesn't work. You know what I'm saying? Yes?
Would that mean that it would also go through 3 and 2?
Yeah, it goes through 1.7. It goes through everything. If you don't have the endpoints, then like anything else can happen. There could be an asymptote, like something can happen. But if you have your endpoints, then you have those points locked in. And if it's continuous, it has to hit every y value from one to the other as it goes from left to right. Does that make sense? If you don't have the endpoints, you don't know that for sure. You know what I'm saying? Yes?
But if it's like parentheses, 1, 4 parentheses, and there's like, if you do stuff and down, like, doesn't it still have y value for
You mean if you're not including the endpoints?
Yeah.
Well, so if you're not including these endpoints, and say, what did I say this was? -2? Okay. And say you're continuous, like on this interval, okay? On the interval, I'll show you an example. Okay, so f of 1 is -2. So, wiggle, 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 wiggle. Okay? Bam. This is a continuous function on the open interval 1 to 4. Do you guys see that? Because I'm not including 1 now, so just to the right of 1. It is continuous. Do you see that? Where like this is continuous on the open interval, this function, all of this. Does that make sense, you guys? This function is continuous on the open interval 1 to 4. F of 1 equals -2, f of 4 equals 3.